Australia has a crater shaped like a spider that almost nobody's allowed to reach. A lake that changes colour on a schedule every single year for a reason science still calls conjecture. A rainforest growing on pure sand somehow when sand should kill it. And an underground ocean older than the dinosaurs that go extinct. 7 more places. 7 things that still don't have a clean answer. Put your headphones on. This one goes even deeper than the last. Before we start, if this is the kind of thing you come back for, hit subscribe now. Most people watching haven't yet, and that means they're going to miss what's coming next. The crater, with a name that came from the shape. The Kimberley. From the ground, it's just rugged, broken terrain. Ridges and gullies that don't seem to follow any pattern. From above, it's unmistakable. A 13-kilometre web of radiating ridges folded and twisted around a central dome, looking exactly like a spider frozen mid-crawl into the rock. Geologists had walked past pieces of it for years without realising what they were standing on. The clue that broke it open came in the 1970s. Shatter cones. Distinctive, cone-shaped fracture patterns that form in rock under one very specific kind of pressure. A hypervelocity impact. Something from space hit this exact spot, hard enough to fold solid sandstone like fabric. Here's where it gets frustrating for the people trying to date it. The impact happened sometime after a geological event called the Yampi orogeny, roughly 900 million years ago. That much researchers can pin down, but the upper limit is still open. Some estimates push the impact itself back into the Precambrian, over 550 million years old, with no tighter number agreed on. 2 competing models try to explain exactly how the impact folded the rock the way it did, and neither one fully accounts for everything researchers see on the ground. As of the last published structural study, the 2 models still haven't been reconciled, and almost nobody's going to check anytime soon. The terrain around Spider is rated as effectively inaccessible. No town nearby, no easy road in. Just one of the clearest impact scars on the continent, sitting in a shape too strange to be a coincidence, that most geologists will only ever see from a satellite photo. Researchers who have made it out there have measured shock effects propagating straight through individual quartz grains in the rock. Physical proof the sandstone was already solid, already fully hardened at the moment whatever hit it made impact. That detail alone rules out a slower, gentler explanation. Something arrived fast, hit solid ground, and the rock remembered exactly how it happened for the better part of 1 billion years. The hole a hunter allegedly already knew about. A near-perfect circle, 880 metres across, rimmed like a bowl someone pressed into the earth. Wolf Creek Crater. It's the largest impact structure in Australia, from which fragments of the actual meteorite have been recovered and confirmed. Not theorised, confirmed. Pieces of the object that made this hole are sitting in collections today. Western surveyors spotted it from the air in 1947 during a routine mapping flight and were stunned that something this size had gone completely undocumented on any map. But the Jaru people already had a name for it, Kandamalal, and a story that had circled it for generations before any aircraft ever flew over the desert. In the story, a rainbow snake burst up out of the ground at that exact spot, and the crater is the wound it left behind. One unverified account claims a local tracker had already shown the site to a police officer years before the aerial survey back in 1935. It was never confirmed. But the geometry doesn't lie. This crater is roughly 300,000 years old, meaning it was already ancient long before anyone with a plane came looking for it. Somebody, at some point, walked right up to the edge of a genuine meteorite impact and built a story precise enough that it's still being told today. Matched almost exactly to what the crater actually is. What makes Wolf Creek different from most impact sites isn't just the crater, it's the fragments. Meteorite material recovered directly from the site has been catalogued and confirmed in laboratories. A rare thing anywhere on Earth, where most old craters have long since had their evidence eroded, buried, or scattered. The rock that fell is still in pieces sitting in drawers, decades after the story that predicted it was already old news to the people who lived there. The ocean nobody's ever seen. There's an aquifer holding an estimated 65,000 cubic kilometres of fresh water. That's enough to fill Sydney Harbour more than 130,000 times over. It's the largest and deepest artesian basin on Earth, and until 1878, when a bore near Bourke, New South Wales, hit water and it came up on its own, under pressure, nobody living on the surface had any idea it was down there. The water itself is older than most people can really process. It started collecting during the Triassic and Cretaceous periods, when much of inland Australia sat under a shallow inland sea. Rain fell, filtered down through porous sandstone, and got trapped there by layers of denser rock above it. Some of it lay down while dinosaurs were still walking the surface. The recharge rate at the edges of the basin, where new rainwater slowly filters in, moves at only about 1 to 5 metres a year. At that pace, water entering at one edge of the system can take an almost incomprehensible stretch of time to travel any real distance underground. At towns like Winton in central Queensland, that ancient water still comes up hot, close to boiling, and under its own pressure, no pumping required, from wells drilled almost a mile deep. A town that by every normal measure shouldn't survive out there survives because of rain that fell before humans existed, still slowly moving underground, only now reaching the surface. The scale of it is difficult to hold in your head honestly. The basin stretches nearly 2,400 kilometres, north to south, and reaches depths of up to 3 kilometres in places. Every drop moving through it right now fell as rain sometime between the age of dinosaurs and roughly the last ice age, meaning some of the water people in outback towns bathe in today has been travelling underground in total darkness for longer than the entire span of written human history combined. It also isn't a passive resource. Mound springs formed by this same basin, where the water naturally reaches the surface without any drilling at all, have supported human life and unique ecosystems in some of the driest parts of the continent for thousands of years. Entire food chains, entire cultural sites, entire small towns, all of it resting on the accident of ancient rain that happened to get trapped under exactly the right layer of rock, at exactly the right depth, in exactly the right place to still be flowing today. The wave frozen mid-break for 2.7 billion years. A curved granite cliff face, 15 metres high, over 100 metres long, shaped exactly like an ocean wave about to crash, except it's stone. And it's been sitting there, unmoving, for longer than almost any other landform on the planet's surface. Geoscience Australia dates the granite itself to more than 2.7 billion years old. Older than complex life, older than an oxygen atmosphere, older than almost anything that's ever going to be filmed for a documentary. The wave shape isn't the age, though. That came later, much later, geologically speaking. Around 100 to 130 million years ago, during the Cretaceous, groundwater got underneath the surface and began dissolving the softer minerals in the granite, while the harder quartz and feldspar held their shape. That process, called flared slope weathering, worked from below, hollowing out the base while leaving the top intact, undercutting the rock until it curved into an overhang. The reds, yellows and greys streaked down the face aren't paint or mineral veins. They're chemical stains, left behind every time rain runs down and redeposits iron and carbonates along the same paths, over and over, for millions of years. Nobody figured out the mechanism until relatively recently. For most of the time, Europeans have known about this rock. The honest answer to why does it look like that was just nobody's sure yet. Put the two numbers side by side and the strangeness comes into focus. The granite itself, 2.7 billion years old. The wave shape carved into it, roughly 100 million years in the making. That means the rock spent nearly 96% of its existence looking like nothing in particular, just buried granite, doing nothing, before the specific chemistry needed to sculpt it into a wave even began. Before any of that erosion started, this same granite was still sitting kilometres underground, completely invisible, part of a much larger dome, buried beneath softer, more weathered rock. It only became visible at all because everything around it eventually wore away faster than the hard granite core could. In a sense, wave rock isn't something that was carved into shape, so much as something that was slowly unburied. The wave was always in there, waiting for 2 billion years of erosion to finally reveal the piece that could survive it. The lake that changes colour on a clock. A volcanic crater lake, 72 metres deep, and every single year, right around the end of November, it flips. Steel grey all winter. Then, over the course of a few weeks, it turns a saturated, almost unnatural turquoise blue, and holds that colour until March, when it flips back. This isn't folklore. It's measured, tracked, and published in peer-reviewed research. And the official answer is still, in the words of one of the more recent studies, a matter of conjecture. The leading explanation involves calcite. As the surface water warms in spring, dissolved carbon dioxide releases into the air, the water's chemistry shifts, and tiny calcite crystals begin forming and sinking through the water column. Those microscopic crystals are what scatter blue wavelengths of light back at anyone standing on the shore. In winter, without that layer of suspended calcite, the water looks murky and grey. That's the leading theory. Researchers openly note that other factors might be playing a role too. The angle of sunlight through the seasons, the movement of microscopic plankton, small shifts nobody's fully isolated yet, a city's actual drinking water supply changing colour on an annual cycle, and the honest scientific position is still probably this, plus maybe some of that. Blue Lake also happens to sit inside the crater of Australia's youngest volcano, one that may have erupted as recently as 6,000 years ago, which, if the newest dating holds up, would make it the most recent volcanic eruption anywhere on the Australian mainland. So the lake that changes colour every November isn't just sitting in old, dead ground. It's sitting in a crater young enough that people may have watched it form. The valley shaped by something that fell from space. The same park famous for its striped, beehive-shaped sandstone domes that look almost too geometric to be natural. Tucked inside it is Picatinny Crater, a confirmed impact structure, its rim still traceable across roughly 7 kilometres, even after everything erosion has thrown at it since. The strange part isn't that it's there, it's how long it's had to hide. Dating puts the impact at under 360 million years old, meaning whatever hit this valley did so while the striped domes above it were still forming layer by layer in a completely different environment. 2 record-breaking natural features born from 2 unrelated processes, separated by unknown stretches of time, sitting on top of each other in the same small patch of desert. Most visitors who walk through Purnululu for the beehive domes never even learn there's a buried impact scar directly beneath their boots. The domes themselves get all the postcards. Those black and orange stripes are bands of lichen and oxidized clay, built up over millions of years of weathering, and they're genuinely one of the most photographed landforms in the country. But almost none of the people photographing them know they're standing inside 2 separate geological stories at once, one written by wind and rain, the other written by something that fell out of the sky. The crater's rim, even now, still traces a rough circle you can pick out on a topographic map if you know exactly where to look. A scar that's outlasted every empire and every language spoken on this continent since it formed, quietly holding its shape underneath one of the most photographed landscapes in the country, while almost nobody looking up at the domes ever thinks to look down. The forest that shouldn't be able to grow where it's growing, formerly known as Fraser Island, is the largest sand island on the planet. 123 kilometres of dunes stretching along the coast, and somehow rising directly out of that sand, there's tall, dense, genuinely ancient rainforest. Trees over 1,000 years old, some reaching 200 metres in elevation on dunes that are, structurally speaking, almost nothing but sand. Sand should not support this. Sand has essentially no nutrients on its own. UNESCO calls the scale of rainforest growing on sand dunes here believed to be unique anywhere on Earth. Not rare, unique. The mechanism researchers eventually worked out. Fungi and lichen on the forest floor break down fallen leaves and dead wood, and as each new layer of dune sand buries the old, that recycled nutrient layer gets locked in and built on by the next generation of plants above it. Over thousands of years, dune by dune, the island effectively built its own soil from nothing but its own decay, one layer at a time, until it could hold up trees the size of apartment buildings. it's still the only sand island on Earth where a rainforest at this scale has managed to survive layer after layer for that long, and it isn't finished changing. Some of the island's dunes are still actively moving, swallowing older forest as they migrate, while new forest establishes itself behind them on freshly stabilized sand. K'gari isn't a finished landscape frozen at some point in the past. It's still being built, one collapsing tree and one new layer of fungus at a time, in real time, right now. That's really the through line connecting every place on this list, and the one before it too. The land doesn't hide anything on purpose, it just sits there, being exactly what it is, indifferent to whether anyone's paying attention. A crater looks like ordinary broken ground until someone notices the shatter cones. A lake looks like any other lake until someone tracks the colour change across an entire year. A patch of sand looks incapable of holding up a single tree until you dig into what's actually happening under the surface, one decayed leaf at a time, for thousands of years running. The mystery was never that these places are strange. It's that most of us walk straight past strange things every day and never once stop to check. If you want more of these, subscribe. This is exactly what this channel does next.